So the RIPA, as you can see on the right-hand side there, we would have an accommodation schedule, which would normally have different room types within different departments and the occupancies of these different rooms. So the occupancies are important because we need to understand how many people are there within a space, within a floor, when we're trying to design a fire strategy for the building. Once we've got this done very quickly, we can start putting together some adjacency diagrams, or bubble diagrams as we used to call them, to see how the spaces relate to each other. And this is very high level right at the start of the project. While that's happening, we start using HLM Insight, which is the tool that I just mentioned. So basically what happens is we send out a questionnaire to the department heads or the clients, depending on what kind of project it is. If there are any trees of significance on the site, what the ecological characteristics of the site are, whether the site's prone to flooding, all these assessments would be made at this stage. We would also at this point start looking at what's around the building, or the building site rather, in terms of building heights, materiality, massing, to make sure that what we're designing doesn't overpower what's already there, but flows with what's on the site. We're also constantly carrying out in the background an environmental analysis of how the actual massing performs. So the orientation of the building itself plays a big impact on the operational energy performance of the building, where the windows are, where the sun's heat's coming from, etc., where the wind's coming from. So all these environmental factors actually affect how the building's consuming energy. Concept sketches first, and then they were modeled, and these models were then run through the computer software with the environmental analysis to see how the spaces behind it were performing, keeping in mind that we've got certain adjacencies and room types behind those facades, which we're trying to meet the questionnaires that we had set through HLM Insight at stage 0 and 1. The M&E strategy is in place. There's a structural design in place. So these designs then get finalized with the client. The costs get finalized, a planning application is prepared, and a planning application is then submitted with this quality of information on it. So this is normally what happens by the end of the planning stage. Something that's quite important as well, probably as important as the building, if not more important than the building itself, is landscape and ecology. To use virtual reality in quite a few of our projects to visualize the buildings. Stage 4, I've not put a lot of slides in, I've only put this one. So stage 4 is basically what in India we used to call working drawings. It's basically detailed drawings to get the building constructed. Stage 5 construction, this is normally when the building's on site. Again, virtual reality is used quite a lot to prevent snagging issues on site, coordinating designs between the different disciplines as well. Put in a section on BIM just to show you how a project develops purely through the BIM model. So I've talked a bit about the environmental aspects and I've talked about the work stages, but I also want to quickly touch on how the actual 3D model develops through the different stages. So this is a primary school in Stockport that I worked on about 5 years ago or so. This was based as a precursor to DFMA. So this was based on a modular system, but it was built in traditional construction, almost as a pilot project to prove that in the future we could build modular, which is what we're doing right now. So then design the fabric around the building. Because these buildings are basically based on a handbook design handed down by the government, there are very strict guidelines in terms of how much daylight each classroom needs to get, how much ventilation each classroom needs to get, even down to the specification of what the carpets are. So any building element is got an LRV, which is a light reflectance value, or you'd have block work. So so at this point, these consultants get involved and they send us their model, which we then incorporate into our master model, and then you get this level of detail in it. And then you can start overlaying the M&E information. So where you've got beams and things, you can very quickly start seeing where there's clashes and what needs to move. So for example, over here, you can see that there's pipes going through these beams. So we'd either need to make a hole in the beam or drop the pipe around it or drop the whole run of the pipe. Information models. BAS 11922 is a project information model, and 11923 is an asset information model. So normally what happens is when the client creates a brief, we have meetings with the client and the key stakeholders, and through a question and answer session, an employer's information requirements set is created. This is a project in Sheffield. It's Holliscroft. This was a 970 bed student accommodation block. Again, this was done in traditional construction because modular hasn't reached out that far into the living and community sector yet. This is a university building for social sciences for the University of Sheffield. This involved a lot of modeling work in 3D. This is not a project that could have been drawn with pen and paper and built. It's extremely complicated, so it did need a 3D model. And we spent a lot of time looking at the environmental impact and reducing the carbon impact of this building as much as possible as well. Building at the back is a historic Grade 2 listed building next to Sheffield Town Hall. So it's just next to a historic public square. So our design intervention here basically is we're reusing this building, we're converting that into hotels, and then there's a new rooftop restaurant and bar at the top.
You talk about the greenhouse effects that are caused by the construction techniques and the processes that are done at the construction site.
Mm-hmm.
So obviously, because of the climate, different materials are used in different projects, depending upon the location. So my question to you is that does the climate actually somehow decide the amount of greenhouse emissions that will be taking place in a certain project?
That is a good question. I don't think the climate doesn't decide the emissions. I think so. In terms of construction, I think India and China traditionally had the right idea where vernacular architecture was really a very good response to climate sensitive architecture, where you would use materials which are local to the site, and you're building a building which is responsive to the climate and the environment. So things like jolly brickwork that Laurie Baker's done a lot of in South India, is very responsive to the climate. What's happened is as time's moved on, our aspirations as an industry and a society has changed in terms of what we think is modern and Western. So the Middle East, for example, all these glass buildings are going up in one of the warmest climates in the world.